Something's gonna bring the change. Journeys we are meant to take. Something at the edge of space, calling us to fly away. Don't you be afraid, everything will change. You and I, jumping off the edge. They say dreamers never die. So come and fly, come and fly, come and fly away with me. We're rising, we're falling, we're making through. We're climbing, we're soaring, 1,000 views. We're rising, we're falling, we're making through. We're climbing, we're soaring, 1,000 views. Come and fly away, come and fly away, come and fly away with me. Come and fly away, come and fly away, come and fly away with me. Something's gonna bring the change. Journeys we are meant to take. Something at the edge of space, calling us to fly away. Come and fly away with me. 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 Don't you be afraid, everything will change. You and I, jumping off the edge. They say dreamers never die. So come and fly, come and fly, come and fly away with me. We're rising, we're falling, we're making through. We're climbing, we're soaring, 1,000 views. We're rising, we're falling, we're making through. We're climbing, we're soaring, 1,000 views. Somewhere by the emerald sea, where the moon and water meet. Somewhere close to harmony, when the world is sound asleep. Something's gonna bring the change. Journeys we are meant to take. Something at the edge of space, calling us to fly away. Don't you be afraid, everything will change. You and I, jumping off the edge. They say dreamers never die. So come and fly, come and fly, come and fly away with me. We're rising, we're falling, we're making through. We're climbing, we're soaring, 1,000 views. We're rising, we're falling, we're making through. We're climbing, we're soaring, 1,000 views. Come and fly away, come and fly away, come and fly away with me. Come and fly away, come and fly away, come and fly away with me. Something's gonna bring the change. Journeys we are meant to take. Something at the edge of space, calling us to fly away. Come and fly away with me. Come and fly away with me.
So, hi. I think we can start soon. Or, I mean, right now. Yeah, I promised someone to start with a macOS rant. Let's start with exactly that. Audio capture. This is something nobody needs, especially not if you want to stream. And this is why we just don't include it in macOS. Who needs it anyway? There's also no loopback device to make up for it if someone, for some strange reason, wants to have it anyway. Yeah. That's macOS. So, what do you have to do to make it work anyway? Yeah. macOS people aren't dumb, so they wrote their own loopback driver. It's called Black Hole. And to download it, you need to subscribe to a fucking newsletter. Or compile it yourself. You have one of these options. I would understand if you had to, I don't know, pay money to get it get a compiled version. That's what Synergy does. I can understand why they are doing this, but subscribing to a newsletter, in which way? I ask again, in which way does this help you with, I don't know, anything except generate more spam? Like literally. I can understand if people want money for a compiled version, but email first name, last name? Why? Tell me, why? It's not ready for Windows. Yeah, it is. Sure, it's not ready for Windows. You have a software for that. It's called Voicemeeter on Windows. You don't need a Black Hole. Yeah, Black Hole may be open source, but you know, Voicemeeter already exists and it's essentially free. Regardless, I wanted to do some coding today. Yeah. On Friday, we made this library. I wanted to press F4. We made this library async capable, so we can put it into async IO code. Most notably, the current version of Django. So this is exactly what we are going to do today, is put this into a Django project. I'm thinking of vendoring this library in, since, as you can probably see, it hasn't been updated since August 6th of 2020. In other words, I consider this project to be abandoned. So this is why I am vendoring it in, so I can essentially maintain bug fixes as needed. So this is exactly what I'm going to do. I'm going to copy these two libraries into the Django project, and this is the first thing. That's easy enough. PyLD master lib. I want to copy it here. I want to do it recursively, and I have two new functions, or functions packages here I can use. So let's continue here. The thing I will need now is something to build a new document. How do I build a new... What do I mean by documents? So let's start with Insomnia to explain how and why I need something like that. As you can see here, this is activity streams. That's not exactly what I want right now. I want this. This is the document for me, for my Mastodon account. And as you can see, it is linking to different stuff, like my outbox. And if I go to the outbox, you can see another document, and in that document you see essentially the posts. The point of all of this is, if I want to have a front end which displays this stuff, I want to essentially batch requests and, more importantly, be able to display posts on them. And if I'm here, you can see some of those posts. This is my outbox. Did I repost anything? I don't think so. So if I go to, I don't know, mastodon.social at Gargon, which is the maker of Mastodon. He has an outbox. As you will be able to see, he has an outbox too. And if I get this, it looks exactly the same. And you might be able to see an announce, and you see the object, but you might be interested in the contents of this object. So what I want to do is essentially define what a document looks like, pull all this data from those different URLs and put them into a new JSON-LD document, which I can then put out on my side for the JavaScript to consume. And this will make everything easier, since essentially I only have to say how this document should look like. And that's essentially all. So let's see. This is the project. Let's wait a little bit with social. Let's add a new package. Document. Let's call it documents. Make it a package. We have a package here. And first, let's take a look at how these things essentially look like. So we get IPython here to make the async part easier. So essentially what I need in this case for development, I want to have IPython. Now it's getting added to this thing, and I can just run IPython here. Takes a little while because of course it has to compile data by itself for some reason. Tests are fun. I love tests. Ah, it continues. So IPython. Let's run tests again. It took a while, but now we have IPython. We can now just import .json. Actually, let's do a from import. And we want to expand. We need some libraries for that. So, what did our flag.nix say? We need all of these. We are going to switch to from HTTP, IRO HTTP away maybe, if their authentication tools are not enough. So, this is what LXML wants. And not LXML, this is for PyLD. And now we have this twice. Let's move in again to make NFRC happy. And now we can, it's not compact, I think the function is expand. JSON-LD.expand to be exact. And we see here the fully expanded document. So, let's see what we can do with this. So, let's explain again how this is going to work. You see stuff like these very, very long keys. Let's save this into a variable called source document, and let's look at the keys. Actually, let's use compact instead. Since I think this may be a nicer thing, yeah. And how was it called again? Base. So JSON-LD.compact base makes it empty, and then we have this one element here. Remove this context. Then we have a good source document, which will help us understand what it looks like. So we have the source document. And if you look at the keys, you will see that each key, ignoring add-id and add-type, which are defined by the JSON-LD spec, is essentially an URL, which allows us to essentially extend documents as much as we want, and compacting a JSON-LD document essentially says that you introduce some namespaces to shorten those URLs again. So The second thing you will notice is that all of those IDs are in themselves fully qualified URLs, which means we can just pull additional data from them. And these in itself are again documents. What does it mean for us in the end? Essentially, we can follow these URLs, get additional data if necessary, and we can then put all those documents together into a new combined document with only the data we want in our in our front end. And this is what we are going to do today. So essentially, if I don't know, want the posts of Garagron, I will then follow this link, run compact with an empty thing again. You will see this document, and then let me follow here. And you see additional documents. And by following them, we can essentially just go in and build a new document with a standardized form that our software can then use without too much batching on their side. So let's start. We can close this. We have this document builder. The first thing we need to think about is how do we want our API to look like. Some already see how. So essentially I want to have a set of functions that I can chain with some operator. I imagine something like this fetch URL, not I don't know, activity pub dot content, maybe not content but outbox, and then I assume it's a collection page dot first, something like that. And this will then follow these paths, loading additional documents if necessary, building a new one. And we need to find additional things. So what this is going to do is this will resolve into a set of commands essentially, which are then interpreted and recombined. So the first thing is we want to set up PyLD for now in a simple way. So essentially the first thing is we want our own routing. Why do we want our own routing? That's very easy. We do not want to call ourselves if we want to pull data from our own path. So what we want to do is we want to have a connector. Connector is a simple callable. It takes an URL, it takes a header dict, and it returns an awaitable with an expanded document. So essentially it takes the headers and returns an expanded JSON-LD document. URL. let's make it a raw JSON-LD an expanded JSON-LD document. So the document loader is essentially the same. URL options, which returns the raw JSON-LD document. So loader is a PyLD document loader, and it returns a connector. So we actually don't need. Actually, we want a context, which is a dict. This is important for later. Essentially, this is for authentication. So we can authenticate ourselves when connecting to other servers. What is a context? We don't know yet, since we are not doing any authentication. And this returns a dict. So from PyLD import JSON-LD. We want to compact it. We don't want to expand it because there is a slight edge case. We want to get this URL. We want to have this space, an empty base. We want a document loader, which is our loader. And we can just return it. Very easy. And now we just need to return the connector. PyLD can't be resolved. Is this by chance? It is not. Maybe. Just restart Vim. See if this fixes it. It does not for some reason. Why not? It's literally in this directory and it's importable. Let's ignore that for now. Let's continue. We now want to process it. Let's make the basic commands. These commands only build a dictionary, so let's call it builder.py. Builds a dictionary. So what commands can we have? We can have a set command. I will use fully uppercase letters to denote commands and lowercase things to denote fetchers, essentially those things that build these commands. The simplest one is just a value. They just return value. And now we have the basics to continue saying I want to have a key with a command. So essentially it takes a value, in this file a dict, in this case it's a dict, and you run the equivalent of running star dict key command dict get key none. And to ensure that this is a dict, something like that. So we have append. This might also be just a list. And it runs this. The problem is if we have a list, we can't just run append set. So what we are going to do is we will allow this command. We will not do this. This is, I think, a bad idea. But to run combine, which takes an any and that do a left fold with the starting value of this any over the command. And that's the new value. So let's start with these 4 functions. What you can see is that value is just the simplest one. It returns a value for typing st. And actually builder is a t.callable, which takes an any, returns an any, done. It's a builder. T.type var returns a t. Builder t, this takes a t. Builder, we'll ignore the first parameter, return value, return builder. Simple. Next one is combining multiple. So commands, which is a sequence of builders, and it returns a new builder. So we need functools, and technically we specifically only need functools.reduce, since this is a left fold, but I prefer to import the whole module, because why not? It doesn't pollute our namespace. So tools.reduce. We have a lambda, previous and next it takes, and we want essentially to successively apply each command onto each other. And we want to do it on commands, and we want to use the init value, and we want to return this. Return the builder. Simple second function done. Now the first actually interesting function is set. It takes a string. It takes a value, which is a builder. Taking t, which returns a builder, returning a dict of string and t. So technically, this is an any. So what we are going to do is just not type it. Not is instant init dict. Init becomes a dict. And with that we can return init. And we can return the builder, but we are not done yet. It's str. I wrote a little bit too much TypeScript at work, but well. So what do we have here? So this is value init.getKey none, and we want to typecast it to this to t to make it shut up. This is technically unsafe, but I find that typings should rather inform how it works and how it's intended to work than essentially than being the end all be all. So in this case, we know init can be any. We ensure that it's a dict. We fake this. Done. But I do agree that we can put it into none. T or none. Then what's the next part? Exactly. This may also be none. And you can see how it spreads. And this is why I do this. Is it completely correct? No, but Python ignores this part anyway, this builder t part. The typings, in theory, this key could also get us integer for some reason if there's a bug, and nobody will stop it. Certainly not a compile time error. So yeah. So the next part is append, which actually takes only a command. Builder t dot list t def builder init. We only care about lists. Init becomes the list. Dot append value t dot cast t none. This is obviously wrong if you look at the typings, but yeah. So these are our basic functions. we can use them to build a dict. Let me show you how this looks like. So Python from documents.builder import set value bind and append. We can now set some key with a value of v, and we should return with a dictionary. We can now combine this. Yeah, it takes only one argument because we don't want spreads. And you can see how this is supposed to work. We can now use append. K becomes value v1. Let's combine it with another append. Set k value v2. And we pass none to it. Combine again only takes one value. And you can see these become multiple entries. And by using combine, we can make more complex things. So these are the basic building blocks. As you can see, there are no fetching from other places right now. This is just dump combining stuff. The idea of my program is to build up these commands. Yeah, that's essentially what I'm going to do, to build them up. And in the end of the day, these will return those things. So this is what we are going to call commands. We will be making two very simple commands for now. We will be of 4, which essentially just build this. This makes our life easier if we fake these connectors or make our own connectors that talk to our database, because these are not stored as a PyLD document, but rather somehow somewhere else, and we want simple versions of these. So let's make some simple functions corresponding to those building blocks. So we have value, set, append, and combine. And the important part of these are that these are commands, and you should be able to chain commands like these. And the idea is that they have a builder. Let's call it command A and command B. And if if you, this will just first call builder A, and on this builder A, this will run builder B on the result of builder A. So the interesting thing is that in this case the commands are asynchronous because they might be calling out onto other functions. So essentially these are import typing is T. This is a callable. It can take anything. It returns an available for a builder. Documents dot builder import builder. There's something going very wrong here. That's essentially what we want to do. So we have a command implementation. And yeah. Let's start with the simple value command. It returns a value combine set depend of a value. Simple. Set key string. So that's the interesting part. Because actually that's wrong. Actually, no, these are just basic stuff. Value, that's another command. So we have a command, it's combine actually these need to be asynchronous. Commands. These are now a variable length because these are not internal. So how are they supposed to work? This part is always hard to picture because this is essentially obvious. We want to have a small set of functions that together build up a data structure which we can then compact again. This one not so much. Let us go through some examples. What we might want to do. we might want to do a fetch. And we want to what does we shouldn't only think about how we want the API to look like. We want to know how objects interact with the thing we are building here. So the fetch in reality does so we get into this. We get a value into this. And this fetch will do one of two things. Either it already has value A, or it will download. Yeah, it will return value A, or it will return none. If value is dict and A in value, step 1, it will return value A. Cool. The next step in our thoughts is a string. We assume it's an URL. Download value load document value. We want to load the document value. Start from beginning. We want to also assert that value becomes a string. There is a trick with this thing. If you have noticed, everything from which we knew in JSON-LD, this is always an URL. So we know that if it's a string, it's a real string, and we also know that if it has an ID, we know it's an URL. So if value is not a dict, return none. Because we can be sure it is not a URL. Present. We can just download it. And copy this. But why is this a separate step? This is a separate step because we already downloaded the document. We don't need to download the document again. So we can assume it doesn't have this item, and we can just return none. So, by thinking about how a fetch works, we can now think about how this fetch on top here works. And how does it work? This fetch A. So essentially, we know that fetch A combined with fetch B first runs fetch A and then gives the value to fetch B. So essentially, we know that fetch, the type of fetch of any command is essentially a function that takes a value and returns a value. Or is A returns a value gets a value, returns a value, but it has a second step. So essentially it talks back, since you know, let's indent it a little bit to make it more obvious. This one returns a builder. And in the end, this one returns a builder also. And now the interesting part is now we need to make it simpler, so we can make a very simple we need to make this a little bit simpler. A command is something that takes a value and returns a builder. Done. So, the next question is, how do we train them? Let's pass it here. What is a chain? It takes a builder. And returns another builder. And the simplest chain is the no-op chain. Which is the identity. And if you do this, it replaces the chain. A combined one. Is it that easy? That's the next question. Is it that easy? How does the value here get propagated? That's the next question we need to think about. When chaining. The simplest way is to let the chain also return the builder and ignore it in the no-op chain. And this one is async. And if we make this async, let's see what happens. Then we can do this entire fetch operation. It's called this fetch, those four things. Return fetch chain. We know it wants to return a builder. It does our new rewriting operation. It takes this and it takes our desired builder. So in this case it's set fetch key is a command. So we have so value chain, and this returns the builder at the end. If we need to await this chain, set v. Essentially it's this. I think. Let's see if it's really that easy. By chaining another fetch onto it. So let's define a chain of C1 and C2. It returns so that's how it essentially works. C1 value chain. When we do this, what happens? It doesn't evaluate C2. So we need to define a new chain. Which returns our builder. And if we do this, what happens? Now use this chain with two fetches and see what returns, and then we are going to nudge this until it looks like we want. So 2 takes the second value, a new chain. It returns a builder. Wait, fetch card 2 with the new value but the original chain. And it will return a wait fetch k1 with the original value. Let's call it v1 c1. But with our new chain. And interestingly, what happens to C2? Feels like data loss. And that's my problem with this. But let's continue rewriting this. Fetch k1 v1. So this c2 is a value in the chain, runs chain, this one. Let's see. This feels wrong. Something must happen with the second. What type is this? So if we go to C1, it runs this. Wait a second, this drops the value. So essentially this one is essentially wrong. We do not want to do this. No. We actually want to run this. This allows the chain thing to continue. So let's start with def sentinel. A chain is callable with a value. It takes a value. It takes a chain. And it takes returns an awaitable with a builder. Def sentinel. Let's use an underscore, which is a chain, which takes a value and the builder any. So builder t any, builder t any. Underscore and builder, and it needs to be async. Return builder. Very simple. That's a chain. So now, knowing that this works like this, This one can be dropped because we are not going to use it. Because these are representations of the same thing. Cool, yeah, we can ignore this. Because these are representations of the same thing, and the chain thing is rewriting this representation. Therefore, we don't have a problem. We can just drop this representation. Done. And knowing this, we can now implement our chain command. It takes a value. It takes a chain, which is by default Sentinel. Chain is Sentinel, returns a builder any. Implemented. Now make a class combine command. Def init. C1 is a command, C2 is a command. Self C1 is C1, self C2 is C2. TheFatRat, make it simpler. C1, C2, self value chain. Sentinel, which is turn await self.c2.run with our value and the second chaining. This needs to be async. And the chain, the value, but we ignore the builder. New value. With that we return await actually C1 C2 dot run new value chain. And here we want the chainer, which returns a builder. We know that this is a chain. Done. Now we can Python shift right operator load. How is it called? shift self other, which is a command. It returns another command. Combine command self other. Command is of course not specified for some reason. One question, what does the flake say? Does it even know which? Does it even? Okay, it does. Okay. Which is a command. Done. Now we can build additional commands. Now we do these 4 basic commands. So the first one is class value. This is underscore because our API design says so. Def init, it takes a value. Value is value. We want the wrapper to have it nice. Async def run self value chain is a chain and it defaults to Sentinel. And this is just a value done. No, I don't. In fact, you are now being blocked, dear service. So, where was I? Combine is, no, the next thing is combine. So let's rename it to chain command. Combine is a command. Self commands. It takes set of commands. Def wrapper, return, combine. Let's make an F string. Actually, all of them need to be an F string. So we want to have a comma separated map wrapper self.command. Async def run self value chain equals Sentinel. So what does it do? It takes the value, applies them to all commands, and puts them into a combine. So we need to import async.io for that because this is a gather operation. And this gather operation is for command in self.commands. And for each command we want to run value chain. This returns as a set of builders. And we want to return a combine of builder. So we want to return them combined. Easy. Next step is set, which is a command. Which is this one. Value, simplest one. This returns a string. Return set self.key self.value async def run self value chain equals Sentinel builders. So we want to return a set self.key, which returns another command, self.value with the chain. Append, which is also a command, is a command value append. In this case, it doesn't have a key, and instead it returns an append, and as I said, it doesn't need a key. So very simple in this case. So we want to make this even simpler. If not is instance value command, value is a let's call it val let's wrap this into a value. Let's do the same here. And now we can go come to the shift and to the fetch command, which is the first interesting thing here. There will be additional interesting commands, but the first interesting one will be fetch, which is a command. It takes a key, which is a string, as always we want the wrapper to have a nice representation. Key. So it is one of two things. So either first let's make it define a source, which in this case is a connector. From documents, the import connector. That's all nice and well, but let's try around with it a little bit. Documents dot commands import set append value and combine. It returns a builder, which if we fill it with none, it returns A. Cool. Let's just chain them. Let's see if it works as expected. And this is where the fetch becomes actually important, because without them we can't actually change the stuff. I mean, yeah, we can do this. Set A value B, but why is this a coroutine object? This shouldn't be a coroutine object. Should actually be something else. So why is this not a coroutine object? Actually, why is this where is it defined? It's a function. I feel dumb, and this explains a lot. Yeah, we can't really chain them. We have nothing to chain. So fetch is the important thing that makes stuff happen in this case. So if not is instance value dict. You know, it's none. So let's create as a fifth builder which does nothing. Unset. Or none. Let's allow that every subbuilder also allows none. Else p ignore this case here too. Value is none, return init or none. If value is none, return init, and value, yeah, it's the simplest one. So and none or none. We return none because we have nothing to chain on it on them. Otherwise, if self.key in value, then we do know something. We can now just turn a value thing value self.key. God, I love my expander in my setup. Our neighbors, they have a very loud discussion right now. I can hear it very well. But the expander is filtering everything out. Not filtering, but noise gating them. That's nice. So, let's see. If self.key is in value. And we also want to self.source is source. Let's make a very dumb connector. Dict is a connector, async def connector. It ignores both, just returns a copy of value. And returns the connector. So it's a dummy connector. Since this is a connector, actually this shouldn't have a context. There's a reason for that. The context, I think, should be added later, which makes all of this a lot easier. So we have a source. It takes if ID in value. This is important. If ID is in value, we want to download it. And this is our new value. Self.key is in value. Return value key. Otherwise, we want to return none. With this, our fetch is done. And now we can show you what fetch is important for. Let's try this. We have an unmatched parenthesis. It needs a key. So we want a dummy connector. Connector import dummy connector. It should take a dummy connector, which always returns an empty thing. Yeah, that's correct. Yeah, that's correct too. None type is not callable. Yeah. And if we have a is 5, it should actually return a builder, but it doesn't. Why doesn't it? Because this one doesn't have a net. Yeah. Any. This returns a builder, which we can call none on. Like this. And if it already has an A, it returns 4. Perfect. So the next thing we want to do is actually, yeah, please. The next thing we want to do is we actually need to be let's add something called raw to it. What is the important part about this raw? TheFatRat value self builder, which is a builder. Return builder. Otherwise, self.key builder. And now we can run self.rep value on this. Exactly, and if we do raw equals true, it returns just 4. Let's set the dummy connector to none. Let's do this. And now chain them, and this is the important part. Fetch none f. It does this again. That's actually not what I want. This is actually not what I want. This returns f equals 5. Actually, this is exactly what I want, actually. Come to think of it, this is exactly what I want. Because if this thing contains more than that, this is the wrong result. This should actually only AF be AF. How does the L get in here? Because we do not use chain. So let's call chain on it. Value chain. Builder is value. If it's raw, if it's not raw, builder is set self.key builder. Return chain, small value, but the builder. So and this one wants the chain. This one too. That is correct too. This makes it async. And we don't need this anymore. So coroutine object is not callable. This needs to be awaited. So F5. Excuse me, what? This should be this should not be F5. We have two ways to do it. Let's see what happens if I do this. I can't imagine that this is correct, but it still only returns F5. I'm interesting. What is value? Okay. So this is setServe.key builder. The key builder. This part is ignored in favor of this. So in reality, we do know that we want to chain late. So essentially, we know that the builder is this, and if it is not raw, then we return builder. Let's see. AF5. And as you can see, L is being dropped. Now we do something interesting. By doing this, A has an ID X, and now we use a dummy connector on the second fetch to illustrate a point. Dummy connector, it always returns ID is X and F is 1, and we care about the parameter F. So this is this fetch, this is the dummy connector, this is this await, this is this run. Why don't you think this is enough? Oh, yeah, sure. So we want this to be a dummy connector. It returns ID is X, F is 1. And now we can say X. And now it loaded this F1 from the dummy connector. And this is the idea of this fetch. So the next important function is the each function. This is a very important command actually. Because this one, the fetch doesn't deal with lists. This deals with lists entirely. So it implicitly is also a combine. So it takes the commands. So it does this, and in reality it does a combine commands. So it has only one command to deal with. TheFatRat, since we know that command is a combine, return REPL f each but we let the command shine through async def run self value chain equals sentinel. It returns a builder. So if it's not a list, it returns none. Otherwise, for item in value, wait async out gather items is async gather, and this is the new value. So we have we need to collect them for item in value self.command.run item chain. Easy enough. And the next part is we want put this into an append, combine items. And the only thing that's missing is chain. Yeah. So that's very easy. Chain value, since this is essentially a no op to the outside, we actually never want to chain from there. But if someone is dumb enough to do so anyway, we just behave as if it's a no op. So what we can do now is say one, and in the second thing, a f is 2. Let's do something unnecessary. A f1. Make f2. Fetch is not defined. That's not a problem. We want an each. This makes funny stuff. And if we wrap it into an each, it errors. Why? Yeah. Sure. So is this being recognized correctly? Yes. So C item chain. We don't need the chain here, to be honest. So like that. And now we see the L2 has been removed. However, if we want to have the L2, we can again fetch, and the L appears here. Nice. So the next thing that's important is in JSON-LD, objects have types and they are defined by an URI. So something like that. If you have an object that looks like this, it listens to this, it has this type. So on types, it is also implicitly combine. So either it's a list of strings or it's a string alone, and it has a set of commands. Is instance types string. Types is a types. Iterable, which returns a string like that. Types is types. Self is a list types. Command is a combine commands. Like that. We want a wrapper. Return on types. This will be very important later. But this is essentially the same as a fetch. So we also need a document loader. So we need a connector. Source connector or none. Source is source. self.source. It needs to be an F string. Self.types. Command. And now we want the run. If not is instance value dict. Return none. And now we want to have fetch bool is true. Fetch is a fetch. If value, if self.fetch and id in value, actually if there is a source. No, if there's a source, we want to get on types differently later. So source is self.value id, and it needs to be await, and the source is not none. Type in value, instance value dict, and type in value, otherwise return none. Run on types. Self value is now ensured to be a dict. It needs a chain, which is a chain, and returns a builder tne. So the return await self.run on types value chain. We know that this is the case here too. JSON-LD type in self.types return not, then we know it's not for us. Otherwise, we know that command.run value chain. We want to just forward this. And this is essentially our basic document builder for now. Let's test this thing real quick. But in the end, we have everything we need to build documents. Let's remove this nice comment. And let's rewrite connectors. Fetch string is not implemented error. So def fetch load doc. Let's call it load document. Key, it returns a command. If the type checking from commands documents import fetch and on types. Actually, commands, this one becomes a string. This direction, type checking, and now we need to find the source. Return fetch self key. Def on types self key command, and here actually types command on types self types commands done. Class LD connector async def load documents def load document self URL. This needs this. Class dummy connector init self. This also needs a document loader def init self document loader document loader self loader value is value def wrapper return connector value air, it's an f string suck async def load document self URL self, it's ignored, return self.value. So and the last thing is we now just need to wrap this. So these will also be capable of async def build document. Actually, no. Since this is abstracted away, we can just do command and returns an any. So target is a string. Or not. Actually, we want to do it here. Async def build document. Base is a string. Command is a command and returns an any. So what we need to do is set this ID to base. Command dot run. This needs a self. This also needs a self. Builder. This array itself dot load document base. Let's do it like that. Document. If builder is none, we return none back. Otherwise, we return a builder, which we run on the document, which we run on none, like that. And in the end, this should return us this thing. We also know that we might want to forward stuff. So let's make a function called reference. It's also a command. In it, it takes actually nothing. It is just reference. We do want to have something. Fetch type, which is a bool, and it's by default false, and it's a flag. The fetch type is fetch type. Fetch type is self.fetch type. And this one is actually no. We want to do it like this. By default, we want to forward both. So ID is ID, type is self.type. Async def run. And we either don't have a tick. If we do, return array chain value combine builders. If at ID in value builders append set at ID value ID and self.id self.type. We want to do the same with type. That's essentially everything. And I think this feeling I'm not working with Python 3.11. Apparently I am, but d.union. So what was the second thing? It was import PyLD connector d dot import yeah. So connector is a PyL document loader dot I think I forgot to inherit. Both need to run load documents, and this one document dot load documents. Build document. Church exit. And let's await it. And we get data back. So the next part is let's load the document for a second. Load document. Sit. Just to see what we can use. Let's do this. Combine fetch. Connector.fetch. 3 were given. Yeah, that's true. I want to build the document, and this should return us a name. We also want the reference. And we want the outbox, something like that. And we need to connect. This is a collection page, so we need to get the .fetch. And we want first. And from that, we have a collection page. That means we need to fetch again. This times items. And to make it smaller, we want from each just the reference. This time it takes a while for some reason. Let's log a little bit. So we want to run this. And we want to run this. And we need a connector again. I said we need a connector again. This one. And as you can see, it's downloading all that stuff and we get back nothing. That's not exactly what we wanted. My tracking failed. So let's restart it. Please tell me it took the right one. Cool. Main properties. Of course. Sure. So, like that. So, why didn't it fetch the items? It did try to fetch them, but then it became empty. Why? So what does the each do? It returns a combine. It never, oh, it changed them here. Runs reference in this place. I think value is a list, isn't it? Ah. is instance value dict and list in value. Value is value at list. I need the PyLD connector. The connector. And this. Now download the outbox and give a list of things. Cool. However, always typing this activity stream stuff is getting tiring. So what we are going to do is make something called a namespace. Get a ttr self name. Dev init is namespace, and we are just gonna concatenate them. So activity pub, let's make a str. The namespace, it starts with this. So problem is, what's an inbox? Because inboxes are a little bit different. I think it was not here, but here. Here's the inbox. JSON-LD playground. You will see soon what I mean. I have an activity, I have a document URL. Use this document. Thanks for giving me it. So let's compact it with a empty thing. This gives us this. And the inbox is LDP. This is because ActivityPub outboxes are an alias of LDP. I mean, inboxes are the same as linked LDP inboxes. Therefore, they have been aliased, so they work the same way. So, what does it mean for us? Our namespace. We need a namespace LDP. And we need to alias them. Aliases. If name in self.aliases return self.aliases name. Stats def set attribute dot aliases name equals value. Done. This is a string. So something like that, then we can do simply from documents.namespaces import activity pub maximum recursion depth get attributes. Let's give it slots, ns and aliases. In namespace dot slots set at name value, else do this. Let's see if this is enough. Again, name in namespace dot slots super dot get attribute name tpub dot name inbox should be LDP outbox exactly. Now we make the rest of the imports. We need the AIO HTTP loader. Let's make the connector. Now we can rename everything. We can, for example, rename these two activity pub.items. Actually, it should be activity streams, but pub.first activity pub.outbox activity pub.name. Now it waits. It takes a long time again. Cool. Like this. And in this way, we can just access these things from other places. So, yeah. I think this was very successful. We can now generate documents. So this was actually far faster than expected. I have a trial application. I worked on it for a week. But apparently this was easier than expected. So, yeah. I'm happy how this turned out. Let's work on it again on Monday. So, or let's implement additional important features. Like the interesting point is that we need additional connectors actually. So we have this document loader. And the next thing we need to implement is a webfinger connector. So what I think the best way to proceed here is that we implement an async def load raw document. Like that. Load raw document URL. Which does just this. And async def load raw document. And now let's look at the AIOHTTP document loader, which returns. I see, it's a document. Okay. So URL. And it takes options. Next thing we implement is a webfinger. Webfinger is actually very easy to implement. Essentially, you look at the spec. You look at this example. You run a webfinger query against the Mastodon server and you essentially know how it works. So it is located at this thing. Let's run cathode.church, well-known webfinger. Resource at cid at cathode.church. Wrong header. 3A40. So 40 40. Why doesn't it find it? Must contain a resource parameter. It actually should find it. Well-known Webfinger. Set to an ACCT. Oh. Okay. I see. So what we are going to search is something that matches type activity plus JSON in the linked tab. And retry with that. So. And here we want the headers. So we do it like this. Headers dict. Headers. Headers. Like that. Let's implement Webfinger from documents.connector, import connector, class Webfinger connector, def init self, parent is a connector also. Def load raw document self URI headers. If URI starts with at or if in URI or ICCT URI starts with then resolve webfinger URI. Resolve webfinger self URI, but no headers because we want to use something different. And if this is the case, we want to return load raw document URI headers. And we want to do the same with load document. Now, if UI that starts with, let's make it a string, starts with a method, cct, UI is URI, but from the 5th character onwards. That starts with an URI from the skipping the 1st character. If not in URI, return none. If URI is none, return none, and do the same down here. Continuing. UI.split at the end. We want two results, prefix, suffix. So dot self dot parent dot load raw documents. We want to use HTTPS if suffix is not with localhost, or suffix dot starts with 127.0.0.1. Then we use HTTPS suffix dot well known webfinger request URI else we want to use HTTPS. We need to URL encode Python URL encode lib.parse.quote. From lib.parse import quote. In question append question resource question append lib.parse.quote, or like that. Quote and ACCT with the prefix. So, and now we want to load the document. Document is array itself.parent.load raw document. And we have an accept header. Location JRD.json if I remember correctly. JRD.json. Not document. Return. Otherwise, we assume it's a if links in document, not in document, we return also for link in links. If type in link, not continue. If link type not application, activity plus JSON, then we also skip this entry. If otherwise, return link href, return none. And this must be document links. Something like that. And now we should be able and now we should be able to do this. Now we should have a WebFinger import WebFinger connector. We want a WebFinger connector passing to a PyLD connector, which is running an IO document loader. WebFinger equals WebFinger dot load raw document at cathode.church. Which also needs the headers, and it needs to be awaited on. Yeah, this is correct actually. Request, and we want to have this empty string join it. And it's empty. Why? Print load UI okay. Let me guess, because this isn't returning. It is actually. Let's see what this returns. Nothing sounds interesting. Okay, this doesn't work as expected. Why not? So why doesn't it work? Hmm. Okay. I have no idea. Raises or returns. Oh, I don't print the document. Yeah, that's dumb. How come the document is none? Because it... Yeah. Better. And now I can return to running this. So not here, but here. Now it keeps running this. We want a PyD connector, we want a document loader, we want a web finger connector, we want to stick them all together, and we want to load them. Load document. Oh, load document doesn't need headers. So let's get those imports again. Let's load the document. And we were able to resolve this into the correct URL. And now we need to just remove the debug logging. Here and here. We need to remove this print. Try this again. And now it hangs again. Cool. Yeah. So essentially, that's also WebFinger support. So I would say I did get very far today. I think next time we are gonna shave additional yucks, like adding support for HTTPX, and since this will be done relatively quickly, we want to also join similar requests and rate limit outgoing requests a little bit. This is our next task. We don't want to essentially go out to hundreds of servers and at the same time if we have a large query. Yeah. So since I did get done quicker than I expected, I will be stopping this stream sooner than expected. Yeah, so I hope you liked it. We will be seeing stuff on a web page very, very soon. We are essentially 90% there. So yeah, I think